Alright, we'll now begin our foray into word problems. This is some of the most pleasant problems that you have in the entire course. Now I know most students don't like word problems, or story problems as they're sometimes called, but I guess they're a necessary evil. Certainly it shows you the applications of mathematics to the world around you. That's one reason why they're important. Eventually, if you take courses in science, business, engineering, those type of fields, you'll obviously see many types of word problems applications, because that's sort of the point of those courses, is to apply mathematics and scientific principles to the world around you. At any rate, this is not going to be too over the top. We're going to try to keep it as straightforward as possible. Nonetheless, students usually find the word problems in the first assignment to be a bit challenging, due in large part to the variety that you're going to come across. On page 33 in the notes is a listing of the different types of word problems you'll see in assignment 1. And there is quite a variety there. Now I'm going to make videos for the different types of problems so that you can go back and zero in on a particular type of word problem if you like. And again, I'm going to try to keep things organized here as much as possible and show you how to look at things. And that's really one of the main ideas you want to focus in on at the beginning here, is how to classify the word problems, how to recognize a word problem for being a certain type. Because if you know what type it is, there's a set of tools that applies to that type, and there'll be a certain approach that you take for that type of word problem. And generally speaking, once you kind of get used to the recipe, if you will, the approach that you're supposed to take for a particular type of word problem, you can get pretty good at it. There definitely is a method to the madness, as it were. But it does take a bit of practice, and probably more practice than maybe other types of problems in the course may take. Perhaps the most important thing I should say, really, about all this is that you can pass this class without ever doing one word problem correctly. That may sound incredible, but it's totally doable, because word problems do not make up a majority of the course. They are a minority. They're about roughly, say, 30% of the course. So you can still pass this class without doing the word problems or even becoming a master of them and so forth. And something else that's probably worth mentioning at the outset here as well is that some word problems are actually pretty easy to do. In comparison to some of the other types of problems you'll be dealing with in this assignment and other assignments, some of these word problems are easier than those other types of problems. So try to keep an open mind to things and learn to recognize the easy word problems, pick those off on the test, and that will free up more space, as it were, to maybe mess up on another problem. So it just gives you a better shot at passing the test if you just pick off the easy word problems. The more difficult ones, okay, just give them your best shot and see what happens, but don't feel like all word problems are evil, because some aren't actually that bad. Now in this video, we're going to focus in on the sometimes referred to as find the number problems. I nicknamed them that because oftentimes the way the problem is worded, at the very end of it, it'll say find the number. And so that's why I nicknamed them find the number problems. Lots of textbooks might refer to these as integer problems. They tend to be pretty dry. Not much of a storyline going on there, but it's usually where you start. In the notes, you'll find these examples I'm going to be looking at coming from pages 34 through 37. At the outset here, I want to just walk you through a couple of translation techniques that will be helpful as you go through these find the number problems and also on other types of word problems. So one of the things I want to take you through is some subtraction phrases, because subtraction you got to be a little careful with, right? If you get the order mixed up, it'll give you the wrong result. It's not like addition, where you really can't mess up an addition, but if subtraction, you can mess that up if you get the order wrong. So let's take a look at a few subtraction phrases here just to show you how to interpret things. And you'll see that's not too big of a deal. It's just a matter of making sure we get the order correct. So we'll have a subtraction phrase, and then we'll have a translation for it. Alright, so here's a phrase for us. How about the phrase A subtracted from B? What does that mean? How do I translate this? Well, we want to get an algebraic expression. It has an A in it, it has a B in it, and a subtraction sign somewhere. How's it going to work? Well, if you think about this, you probably figured it out correctly. The way this gets translated is B minus A, isn't it? Because you're subtracting A from B, aren't you? A is subtracted from B. A is taken away from B. So it's like you're starting with B and subtracting off A. If I wanted to give you a quick numerical example, suppose you had something like, let's say, 20 subtracted from 100. how much would you have there? You would take 20 away from 100, wouldn't you? Which you can get 80. And so the way you translate that would be 100 minus 20. That's what we're talking about. 20 subtracted from 100 is 100 minus 20. So that's all we're doing there. All right, let's try another phrase here. That wasn't too bad. Similar type of phrase here. How about A less than B? What is that going to be? It's pretty much the same idea, isn't it? You're starting off with the B, and you're going to go down from there. So it'll be A. You're going to go down there from at A, and that's A less than B. Probably best to go ahead and do a numerical example again. Suppose we have, say, 40 less than 90. Okay. What is that? I'm 40 below 90. How would I get there? I'd start at 90, wouldn't I? And go down 40, which would give you 50 in the end, isn't it? Yeah, so very similar to the A subtracted from B. Most students don't tend to foul up either of these. The third one here I'm going to write down, this is the one that sometimes gets fouled up. I'll kind of explain why as we go along here. It looks pretty innocent at the outset. The difference between A and B. All right. Now, how does this work? Well, the way these are designed to work in these word problems is when they say the difference between one thing and another, whatever they mention first goes first, minus off whatever they mention second. So the difference between A and B is simply going to be A minus B. Now, the reason why it sometimes gets fouled up is because in everyday conversations, when somebody asks you to take the difference between two quantities, two numbers, you'll usually do whatever you have to do to make sure you give them a positive answer, because you don't normally use negative numbers in everyday conversation. That's usually a more technical context, right? Like you're discussing your math homework, that's how you might have a negative number. But in ordinary conversations, you usually don't use negative numbers, and so you tend to subtract things in a way that will give you a positive result. For the purpose of these word problems, let that go, because we are in a technical context. We're solving a word problem, so the point is, when it says the difference between A and B, they mention A first, you write it down, minus B second. Just do it in that order. First thing first, minus the second guy, and you'll be fine if you do it that way. If you try to turn it around because you're thinking just ordinary conversationally, that's going to foul things up. One other thing I want to show you here with regard to these find the number problems or integer problems is how to deal with consecutive integer phrases. And this is going to make these consecutive integer problems you'll come across really easy to do. So let's go ahead and put down a consecutive integer phrase here. All right. And then we'll have the translation over here. All right. Now, what's a consecutive integer phrase sound like? That would be something like this. Let's say two consecutive integers. So sometimes you have these integer problems, these find the number problems that will talk about two consecutive integers. What does that mean? Well, integers, of course, could be numbers like 3, 4, 5, 6, 7. They're you think of them as whole numbers. They could also be negatives like negative 2, negative 3, negative 4. But they're whole numbers, not fractions. And when they're consecutive, that means they're right next to each other, like 4 and 5, 9 and 10, 17, 18, that sort of thing. The point is, if you know they're consecutive, there's a way to represent both numbers using only one variable. That is, you don't have to bring in two variables. You can bring in two variables if you like. You can use, say, x and y. But let me tell you that in general, when you're solving word problems, the fewer variables you use to solve the problem, generally speaking, the easier the problem's going to be, the less complicated it's going to be, because every time you bring another variable into the mix, it's making the problem more complicated. Now, there's a time and place where you have to use more than one variable, and you're going to set up a system of equations to solve the problem. That's going to take place for us in assignment 2. We don't have to worry about that right now. Nevertheless, if you prefer to use two variables, you're certainly welcome to do that. I'm not saying you have to only use one variable. But in this assignment here, I'm going to focus on only using one variable because, in my opinion, it's generally speaking the easier way to go. Because fewer variables, less complicated problem, easier to solve. So how do you do that? How do you only use one variable for two numbers? Well, you take advantage of the fact that they're consecutive. They're right next to each other. And so that would be something like 4 and 5, right? Or 9 and 10. How does that translate? Well, if you let x be the first of the two consecutive integers, the smaller of the two, then the next integer right above it would have to be one more than that, right? So the next integer right above x would have to be x plus 1. And so there is how I can represent both integers with a single variable. And that's being very efficient. That's taking advantage of something they're telling you when they have consecutive integers. And it's a good idea to do that. Like I said, in my opinion at least, fewer variables, one variable in this case, that much the better. In fact, let's go ahead and extend this idea to 3 consecutive integers. See how that works. 3 consecutive integers. All right, now we're talking about, say, 4, 5, 6, or 9, 10, 11, or 21, 22, 23. 3 consecutive integers. And again, they're right next to each other. So if I let x be the first of the 3, then the next integer right above that would have to be one more than that, so that'd be x plus 1. And the one right after that would be, what, x plus 2? There you go. I have all 3 of those numbers covered with one variable. That's very efficient. Much preferable to, say, using x, y, and z, 3 different variables, because that's really going to make a mess of things. So take advantage, when they tell you you've got consecutive integers, take advantage of that by using a single variable and then just adding a 1 or 2, whatever you need to do to account for all of them. This will also work for problems that involve consecutive even or consecutive odd integers. Let's take a look at that phrasing here. So let's do, let's say, 3 consecutive odd integers. All right. Now, when you have 3 consecutive odd integers, that would be something like, say, 5, 7, 9, 21, 23, 25. So you're skipping by what? By 2's now, aren't you? So if I let x be the first of the 3, the next odd number above that has to be 2 above that, so you'd say x plus 2, right? And the one right above that is going to be 2 more than that, so x plus 2 or x plus 4. There you go. I got all 3 of them with one variable. Again, very efficient. If x were, say, a 5 here, this would be 5, 7, 9. If x were, say, 29, I'd have 29, 31, 33. So that's the way to do this type of problem. Take advantage of the fact that they're consecutive, and since you know they're odd, they're skipping by 2's. Let's also throw in here, let's say, 3 consecutive even integers. 3 consecutive even integers. What's that going to look like? All right. Well, that would be something like 4, 6, 8, right? Those are 3 consecutive even integers. 4, 6, 8. How much are you skipping by? You're still skipping by 2's, aren't you? To go from 4 to 6, you got to skip by 2. So the translation, interestingly, is exactly the same as before, because I skipped by 2's. At first glance, you might be thinking, well, wait a second. How can it be the same for both even and odd? It seems like that wouldn't work. It works because the pattern of skipping by 2's is the same. What's different is where you're starting. If you start with an odd number and skip by 2's, you'll stay odd. If, however, you start with an even number, like 4, and skip by 2's, you'll stay even. So if I start with a 5, it'd be 5, 7, 9. If I start with a 4, it's 4, 6, 8. So it's because you're skipping by 2's that you have the same translation. The underlying pattern of skipping by 2's is the same, and that's what makes the translation the same. The difference is the assumption that x is either odd or x is even, and that's going to make you either have 3 even numbers or 3 odd numbers. At any rate, these translation tips right here, this idea, this technique, this approach, that's going to be very helpful when you get to consecutive integer problems. They're not hard to spot because the problem will talk about being, having 3 consecutive integers or 2 consecutive odd integers, something like that. You'll see that directly in the wording of the problem. You'll know what to do because these translation templates are ready to go right out the gate, and they'll make the problem very easy to set up. We'll do an example like this a little bit later. In fact, let me go ahead and end this video now with this sort of overview of how to translate, and then we'll actually look at some examples of solving these find the number problems in the next video.